Assalamu alaikum and a very good day to everyone. My name is Anisha Binti Suhaimi, student from University Malaysia Sabah. I am the presenter for today on behalf of my team. Today, my presentation will be on the topic of peat soil behavior stabilized with agricultural waste and byproducts material.
The content for today's presentation is divided into four main topics, namely peat soil, eco-processed pozzolan, followed by soil compaction, finished with shear strength. Without further ado, I will jump straight into the presentation. But before we proceed to the first main topic, let me explain the abstract for my study. Peat settlement behavior is a classic problem in construction. The dominant feature of peat is when subjected to load, it is noted for its great compressibility, high moisture content, poor shear strength, and long-term settlement. Tropical peat soils are reportedly connected with the highest settlement when loaded over an extended length of time. Buildings constructed on peat soil have excessive settlement, which leads to instability issues like short-term and long-term settlement even under mild strain. When given current conditions, several construction projects and coastal high-rise structures, whose foundations are frequently supported by peat soils, encounter difficulties. There are relatively few historical studies in the area of peat soil stabilized with eco-processed pozzolan. Much of the literature emphasizes on peat soil stabilized with other waste materials, for instance shredded waste tire chips, fly ash, lime and so on. This study adapts the method of triaxial to stabilized peat soil with eco-processed pozzolan consolidated undrained triaxial cell. The objective for this study is to investigate the index properties of peat soil, to evaluate the shear strength of peat soil under consolidated undrained triaxial test, to determine the effects of eco-processed pozzolan on the shear strength of peat soil, and to assess the mechanical properties of peat soil stabilized with eco-processed pozzolan before and after the treatment. Next, I will explain on the introduction of peat soil. In the literature, peat soil is defined as the organic surface layer of a soil consisting of moderately decomposed organic matter, primarily derived from plant material that has formed under conditions of waterlogging, depletion of oxygen, high acidity, and depletion of nutrients. Peat soil is encountered in many areas and generally originates from plant-animal remains and is considered partly as decomposed biomass as claimed by Adnan and Wijayasekara 2007. Peat soil is appraised as one of the problematic soils. The bearing capacity of peat soil is very low and apparently controlled by the water table and presence of subsurface woody debris as reported by Andres, 1998, Hashim and Islam, 2008a. Excessive settlement happens when buildings are built on peat soil and thus creates problems of instability, such as local sinking and long-term settlement, even if it is applied to moderate pressure.
There are 8 index properties that are investigated in this study, which are degree of humification, moisture content, organic content, fiber content, specific gravity, liquid limit, pH test and compaction. These are some of the tabulated latest study on peat soil index properties. Following next is the compressibility and consolidation of peat. Compressibility is the property of the soil that under the action of an external compressive load, causes it to deform. The magnitude of a soil settlement depends on many variables, such as density, void ratio, grain size and shape, composition, and the soil deposit's past loading history. Consolidation is the compression of wet soil under constant static pressure, which is entirely attributable to the evacuation of water from the voids. Fine-grained soils, such as silts and clays, are prone to consolidation. Moving on to the second topic, eco-processed pozzolan or EPP. Pozzolan is a solid waste produced from spent bleaching earth, SBE, after the residual oil extraction process has been completed.
Spent whitening earth, SBE, is an industrial waste created mainly from the processing of edible oil. EPP has been used as blended cement recently. Research on EPP as a pozzolanic material from previous studies is minimal. Waste products with pozzolanic properties are used for cement replacement in concrete, thus reducing the use of cement. The use of pozzolanic material for cement replacement could reduce the cement industry's release of carbon dioxide, CO, because cement production contributes to 5% to 7% of global CO emissions in keeping with Benalal et al. 2013.
The original EPP was visually found to be mostly coarser and porous in nature. The scanning electron microscope, SEM, image of the EPP shows that it has an irregular, sharp, uneven, and porous structure.
Rayana Farahia et al. 2020 has done analysis on the physical and chemical properties and differentiate and compare to ordinary Portland cement, OPC. The differences were shown in table below.
This is the image of EP in powder and micrograph form. For the physical and chemical properties of EP, it was differentiate with OPC by Rayana Farahia et al. 2020. For compaction test, compaction is a technique for improving the density of soil mass by reducing voids while increasing the amount of water in the soil. The density of the soil is at its maximum value when it comes to the ideal water content. The amount of water provided after that will result in a decrease in soil density. The standard Proctor test and the modified Proctor test are the two types of compaction tests that are commonly used. Then, we will move on to the shear strength of peat soil. Peat is a form of soil that has very minimal shear strength, yet consolidation may result in a huge strength improvement. Peat's shear strength is dependent on a variety of elements, including moisture content, degree of decomposition, and mineral concentration. Monroe, 2005, asserts that shear strength decreases with increasing moisture content and decomposition. In addition, shear strength increases with increasing mineral content. Peat that is shallower and more fibrous tends to be stronger than peat that is deeper and more humified. Kullock, 2006. The soil will fail or deform when the maximum shear strength is reached. The stress-strain connection is used to establish the failure criteria, and the idea of elasticity theory is also used. The amount of strain in soil is influenced by a number of factors, including the amount of applied load, the makeup of the soil, previous stress history, void ratio, as well as how the stress is administered. Angrani, 2006. Then, this is the image for relationship between shear strength and water content. Last but not least, is the tabulated peat soil stabilization method that has been done before.
Most research on peat soil stabilization has been carried out with other agricultural waste and byproducts materials such as oil shale ash, pozzolanic additives, sago waste, ceramic dust, sugarcane bagasse ash and others. The vast majorities of the waste and byproducts material that have been investigated possess pozzolanic properties. Several lines of evidence suggest that natural peat soil's physical and chemical properties can be improved to gain better strength and outcome for construction. Ergo Reichman et al. 2021, stated that Estonian cookersite, oil shale, from both pulverized firing and a circulating fluidized bed incineration process can be used as binding agents for peat stabilization. Sazi Nordzima et al. 2021, points out that stabilized peat, which is composed of 25% partial replacement of OPC with sago waste, discovered to have peak UCS, 17 times higher than untreated peat sample. A recent study by Lily Suhaila Jacob and Amelia M.D. Som, 2020, involving peat soil stabilization using OPC and MGO concluded that peat soil stabilization using MGO and spent garnet improved the strength of stabilized peat. Another study on the behavior of peat soil by Sayohada Fatin et al. 2020, using ceramic dust also reported that mixing a proportion of ceramic waste with the treated peat soil, it appears to have a higher strength. Arami et al. 2020, found that the peat soil becomes more cohesive as more cement is added, while Natsachil Sama et al. 2019, identified that treated peat with SCBA, PCB5, has the highest UCS and was discovered to be equivalent to PC specimen. In conclusion, settlements have been reported on buildings and bridges, road embankments, dams, and several have sought to minimize these losses. In order to increase the strength of the soft tissue soils prior to the start of such construction activities, soil improvement techniques are being implemented. Increasing strength, controlling shrinkage and swelling, controlling permeability and reducing water pressure, avoiding physical and chemical changes due to environmental conditions are the purposes of such improvement techniques. Building on peat therefore requires a large amount of uncertainty, as all theories of textbook bearing power, consolidation and shear strength are based on inorganic soils. Therefore, there are many obstacles and barriers to building construction on soft soils, even on peat. The failed and damaged buildings have a significant effect on the city. It is therefore necessary to carry out special work and further study on peat in order to resolve this challenge and to better understand its actions. Attached herewith is the references I used in this presentation. That brings me to the end of my presentation today. Thank you very much for listening and giving me your full attention.